Hello. So in the last video you have seen what is a metadata. So metadata is a collection of data about the data. So what is the data about the data then? So if you see this picture, um, this is the example of a SQL Server Management Studio database. So in this database here in the left panel, you see the arrangement or collection of all the databases, tables, views, um, server objects, all those are present in the left panel view. Like you can compare it with the Anaconda Spider for Python or Eclipse for Java, where you usually see your files, your scripts in the left hand panel. It's similar to that, and this here it's called Object Explorer. Now in the top part, if you see, when we select this object dbo dot lg customer, so it shows all the fields or the column names are present and what are their data types and which are actually enabled by using this tick signs. Now for each field it again exposes or presents all the details of about that field. And now here in the right hand panel, in the properties panel, it shows again some additional data about its identity, in which way the table has been designed to other tables, how it has been how it's being related to. So all this data can be seen here in this format, which is called as metadata, and it's specifically for SQL Server. In the same way, you will find it in other DBMSs also. Let's say MySQL or PostgreSQL or Microsoft Access, any other. Let me just minimize this one. Okay. Here now let's come to the role of DBMS, its advantages and its disadvantages. So before going to that, just see this picture. Here you will see various end users, to PCs or systems, a database management system, and a database structure. So, what does it explain? It actually explains the role and advantages of DBMS and how the DBMS manages the interaction between the end user, that is the customer, or maybe the database designer, um, and the database. So DBMS, the database management system, is a collection of programs that manages the database structure and controls the access to data stored in the database. So the DBMS receives here this one. This receives all the application requests and translates them into the complex operations required to fulfill those requests. The DBMS hides much of the database's internal complexity from the application programs and the users. So this is the major functionality of the DBMS. Okay, so before going to this, let me just speak about some of the advantages here. So some of the advantages here are, okay, some of the advantages are improved data sharing. So DBMS always helps create an environment in which end users have better access to more and better managed data. And such access makes it possible for end users to respond quickly to changes in their environment. It also emphasizes on better data integration and minimize data inconsistency and improve data access. So DBMS makes it possible to produce quick answers to ad hoc queries from the user. So from a database perspective, a query is a specific request for data manipulation. So let's say, for example, to read or update the data issued to the database. We will see that how it is carried out, how you will query or fire query to the database, and how database will show you or present you the output according to your query. We will get into that now. Let me see. So after this, we have types of databases. So if we are learning about database system, we must know what are the different types of databases that are present. Um, So here, classification by number of users. So how many users can use the database? It can be single user. Let's say desktop database. You are currently working in your own individual database. When you start working with the SQL queries, you will install your SQL server or other DBMS into your system, and then you will start working with the queries and their outputs. So that's it. That is one example of single user database. Your personal computer. Multi-user database is which supports multiple users at the same time. So there will be one computer with a CPU or central processing unit, which will be responsible to carry out all the queries, their processing, um, the query requested from other systems or other terminals, you can say. So one example can be work group database, which supports a large number of users or a specific department, or enterprise database. So let's say you are in a classroom, you are studying database systems, correct? Database development. So here you are working on the college provided PCs or the workstations. So these are not here an example of single user database. That's a multi-user database. So here you are actually working your own provided PC. You're actually working in an image which is created in your by your IT department, and the IT department has a system, or you can say as a server, where they can control all the functionalities of the systems or the your own provided individual machines from their end. So this is one example of multi-user database. So your systems are always controlled by the IT department. Now, classification by location. So centralized and distributed. So centralized is something the data is located at a single site. So let's say you are signing up for your courses, right? Your own university or the school database, all the 12 community colleges database are in a certain one place, okay? And they are all controlled from that single site. Distributed, which the data is distributed across different sites. And cloud database, that today, here now, the cloud is mostly used, and one example can be Microsoft Azure SQL database. Okay, the cloud based is actually, what is this? The cloud vendors, there are so many vendors, and Azure SQL database is one of them. So cloud vendors provide many tools for bringing large batches of data into their platforms. This includes database migration or replication, that is your duplication, processing of transactional changes, and physical transfer devices when data volumes are too big to send efficiently over the internet. See, Amazon has its own cloud. Um, Microsoft, Google have their own cloud. Okay, now they have their own cloud services. So in that way, I started with saying cloud vendors. Next, why database design is so important. Okay, why should we emphasize on database design? So modern database and application development software is so easy to use that many people can quickly learn to implement a simple database and develop simple applications within a week or so without giving design much thought. So as data and reporting requirements become more complex, those same people will simply or quickly produce the required add-ons. So there are some points we need to stress on. Those are good applications cannot overcome bad database design. The existence of DBMS does not guarantee good data management, nor does it ensure that the database will be able to generate correct and timely information. Ultimately, the end user and the designer decide what data will be stored in the database. Okay, let me tell you this example. Okay, so this is one kind of, you have seen here to lines or bullet points, well designed database or poorly designed database. So I'm going to show you the poorly designed database. Here, what is this? So this is one table, or you can say database, and which has individual column names and their respective values in the individual rows. So see here, where there are blanks in the rows 9 and 10, is it efficient? Is it a well designed database? No. So let's say you want to produce or generate a alphabetical listing of employees. Can you do that? And if so, how can you do that? Is it possible? Then how to count how many employees are certified in a particular skill? Let's say basic database manipulation. How to find out that? Now there are some other queries like this. Try to read this. Okay. So this is one example of a well poor designed database. So how to get a good design from there? So see, if you see the picture, there are three different informations involved: employee information, certification, certified information, and the skill information. Okay, so if you divide all those details into three different tables or databases, then it will be easier for you to answer all these queries. You do have these pictures in the book as well. Okay, if you have the physical book, or if you don't have, also you, if you are using the Cengage Mind tab, also you will have the digital copy of the book. Just open the book and try to find out your answer using these three divided tables for all these questions that you have here, five questions. And then you will be able to understand what is a well designed and a poor designed database. Next, come to evolution of file system data processing. So at first, from the beginning of the time, there was no DBMS. So initially we had manual file systems. Okay, in this way you are storing the files, computerized file systems. Okay, or you may have used Microsoft Excel spreadsheet programs, right? So if we had all those things, so why do we found an idea that we need to improve or we need to create the DBMS? There is so much to it. Okay, see, so you can have one question in your mind, that what are some basic database functions that a spreadsheet cannot perform? See, spreadsheets do not support self documentation through metadata. No metadata. Enforcement of data types or domains to ensure consistency of data within a column, define relationships among tables, or constraints to ensure consistency of data across related multiple tables. Like, this is not answerable through all these initially used database systems. So that is why we went into developing the DBMS. Now, this is something you can relate to. Okay, some of the terms associated with the database system: what is data, field, record, and file. This is an example showing a simple file system. What are the advantages and what are the disadvantages? Now, some problems with the file system database system. So these are the key terms: lengthy development times, manually you have to develop it; difficulty of getting quick answers; complex system administration; lack of security; and extensive programming. So these are the problems. Now let's come to structural dependence and structural independence. So let me first start with structural independence. So what is this? When a data access program are not subject to change, when the file structural characteristics such as number or order of columns in a table change. And structure independence is important because it substantially decreases programming effort and program maintenance cost. And just the alternate or the opposite is your structural dependence, because any modification to file system may not be established successfully in regard to. or in opposed to your structural independence. Let's take one example of structural independence. So, for example, adding a customer date of birth field to the customer table. Given this change, none of the previous programs will work with the new customer file structure. Therefore, all the file system programs must be modified to conform to the new file structure. Now, next is data redundancy. So, for explaining data redundancy, it will be easier for me to take you to this two next slides. So, this figure 1.7, it is the customer file or customer table, and this is the agent file or agent table. See, what is data redundancy? Data redundancy actually exists when unnecessary duplicate data are found in the database. For example, a customer's telephone number may be found in the customer file, but in the sales agent file in the invoice file. Data redundancy is symptomatic of a computer file system given its inability to represent and manage data relationships. Data redundancy may also be the result of poorly designed databases that allow same data to be kept in different locations. So this is what data redundancy. Data redundancy is nothing but data duplication. Let's see these two tables here. Okay. So to understand data redundancy, we need to know another key concept called data anomalies. So what are data anomalies? These are developed when not all of the required changes in the redundant data are made successfully. So there are three different types of um, data anomalies, that is update anomalies, insertion anomalies, and deletion anomalies. These are the three data anomalies. So let's try to understand each one of them through these two tables. Okay, so update anomalies. So this is something. So any update in one field for a field needs to be updated everywhere if it has been used in multiple places. So let's say one of the agent's phone number is changed in the agent file. So what will happen then? So that agent which is related to a particular customer, okay, in the customer file again for the changed phone number of the agent name, you need to change the phone number also in the customer file. So that means what? If you make a change at a certain place in a database, in one table, in another table which is connected to that table in that database, in the particular database, will also need to be changed, or otherwise there will be problem or error. That's what your update anomaly is. Insertion anomaly, let's see in this picture, if we need to add a new agent, correct? Okay, so here let's say we are going to add a new agent here to this agent file. So in that case, what will happen? We also need to add a dummy customer entry in the customer file to reflect the new agent's addition. And what is that dummy entry? That dummy entry means non-valid, invalid data which can be shown by or presented by a null. We have one null entry. While building databases using SQL queries, you will learn that. Now, deletion anomaly. This one, third one. So deletion anomaly is if we delete one of the customer's data from this picture customer file, then the related agent's data will be lost too. That is deletion. That is deletion anomaly. Okay, so this is about anomalies. Next, database system. So logically related data stored in a single logical data repository. Okay, so physically distributed among multiple storage facilities, DBMS eliminates most of the file system's data inconsistency. This is your database system. This is one picture of it. And in the current generation DBMS, this is our current generation database system, and this is the previously used file system. In the current generation DBMS software, it stores data structures, relationships between structures, and access paths. Now, next comes our database system environment. So, what is that? This is one example of it, and the um, main entities associated with it are the hardware, that is all physical devices or storage devices, network devices associated, software, which means the operating system software, TBMS software, and the application program software, people. And what are those people? Those can be the system admin, database admin, database designers, system analysts, and end users or programmers. Procedures. So, procedure standards are the instructions or rules that govern design and use of database systems. What is data? Data are the facts stored in the database. And these are some of the key points or entities associated in the database system environment. Next, lastly, we will come to DBMS functionality. So, some of the DBMS functionalities are dictionary management, storage management, data transformation, and security management. Elaborately, please see your book and go into the details of it, of each of the functionality. Okay, so here I have shown you the SQL Server. So this is another one, Oracle DBMS. You may also install Oracle if you want to. You don't if you don't like SQL Server or other DBMS. And this is a structure of a data storage management in the Oracle. Okay, so as you are learning database systems, you should be familiar to the professional career options available. Here I have included this table for it. You can be a database developer, designer, administrator, an analyst, architect, consultant, security officer. You can also work in cloud computing services as data architect and data scientist. So these are some of the future opportunities available after you acquire the knowledge in your database system.